welcome to this session. Today we will look at how we've helped a company called Bollhoff to improve their design efficiency with moving all their data over to Creo and using the GENIUS Tools suite as well as part of the solution. First of all, we look at the agenda. So what we'll look at is what is the GENIUS Tools suite, existing and new Bollhoff data, so how they currently do it and what we've done, and then why did we use the GENIUS Tool solutions for the project, and how we transfer the data and verify that we've done it correctly, and then lastly, what is the next steps in this project. So first of all, what is GENIUS Tools? So the GENIUS Tools products is a suite of products or solutions that has been developed by INNEO for our customers, and we've developed some tools that will run inside Creo, some applications that will run inside the Windchill products, Modelprocessor, which is a standalone application that allows you to do rework on your CAD data, and then also the environmental configuration tools, the Creo Starter application that's being used for controlling what happens in the background in your desktop CAD design applications. And in this presentation we'll focus on the design applications, the model processor, and then the starter application. So in a typical working environment with a CAD system, you normally have a licensed server. You'll have, if you're using a program like Creo, you'll have startup commands that will allow the user to start Creo with different licenses, and you'll have your parametric CAD data. So this could be drawings, assemblies, parts, and you'll also then have, most likely have your standards where you've got your start models, drawing borders, your different config settings, your drawing setup files, your printing options, materials, library items, all the typical things you would have in your standards that people need to access to use the software. And how do you manage all of this? So normally what people would do is they will have everything on a central server, possibly with some map drives that is controlled by an administrator, and then the users will access this from the server through the map drive, or maybe a batch file that they'll use to start up the software and copy files and then carry on working. Okay, you could possibly also have, if it's a big organization, you could have satellite servers that sits in different countries, or maybe just in a different building or a different town, where people will then access the information from that server. So the data has to be synchronized from one server to another server, maybe through a batch operation, or every night through a script or something that will update all these tools. So in the GENIUS Tools suite of products, we've got the GENIUS Tool Starter application, and this is a simple application that will access this data and manage it and synchronize it out to all the different workstations. So if you need to make a change, you'll have the administrator that's got access, and it will set up all the information the same way as you would have with a normal installation of your network settings. But if he then makes the changes, it will be synchronized or sent up back to the server, and that will then be uploaded, and then it will only download everything that's changed to the actual user once it's synchronized to their workstations. So it's not a process where you have to run a batch file again. All of this will happen automatically in the background through this starter application. So in the starter application, we could also manage multiple CAD systems. It's not just the PDC systems. It can manage all the Creo products. It can manage other CAD systems such as SolidWorks, Inventor, and AutoCAD as well. And we're in the process of expanding this to support applications such as CATIA and NX as well. You can also launch non-CAD related applications from this tool, so it makes it nice and easy for a company to give access to people, or to have a central point where they could access all these tools without having to access network drives and other applications. So the benefits of using a tool like this: you don't need to have all these batch files running in the background and syncing files. When this tool synchronizes the files, it will only synchronize the files that is actually changed. It won't take a long time every time to copy all the data from the server to the actual workstation. And you also don't have a problem with slow networks, because you don't have to connect to the actual network to access the data. all the data is copied locally onto the machine, and that basically means you can take your machine, go anywhere in the world, install, start up the applications, and use the software. So what does it look like? So this is an example of the interface. So let's say you've got someone sitting inside China. He will have the different applications that he can start up. So on the left hand side you can set up different groups and different bits of office information. If you have someone that connects from a different location, maybe from the UK, if we look at tools such as, let's say someone needs to log in from a different location, you'll now see that he's got more options: access to your Windchill server, access to your Navigate server, so you don't need to send them links and save it in favorites in the browsers. You set up a simple link, the user can click on it, start it up, and you can access that data. If you have other CAD systems, it can be started from this one. You could set up multiple groups on the left hand side. You could have things like standard office applications. So in this example, there's, let's say you've got a new starter document, you don't need to email it to the guy, have it in a central location. If that document updates, it updates for everybody inside the business. So you could open up different document types from the starter application. You can set up shortcuts to files on the server. So as an engineer, you often have to browse to things or locations on the server where you have many subfolders, and this would mean that you have to either somehow create shortcuts or go to different locations many times, and you have to remember where all those things is. With this, it just makes it so much easier to get to all those locations. Another example, let's say you're not using a PDM system, you've got Word documents, a change request form as an example that someone needs to complete. You could have the template on the server. If you make a change, it's synchronized to the people. They can easily access that and use the information. Same with email templates. You need to, as an example, fill in a leave form. You have it as a Outlook template, put it on the server, people can access it from this application. If you need to access supplier information, so maybe where do you buy your parts from, you could have all of those controlled as well. If the company then later on decides maybe we buy parts from this supplier and we don't want people to use the items anymore, you don't have to send out lengthy emails and tell people to go and delete the favorites, or you can make sure that nobody goes to that site by accident by just simply removing it from the starter application, and that will then immediately let people know that they don't need to access that site. Same with material information, color codes, finishes. You could have all those things in the application, and the same with accessing any other of the PDC products. Then the next one is starting the actual Creo application. So if we look at, as an example, this one is set up to have two different startup commands for the users in the UK. The top one will have more options at the bottom one, where we can then specify the licenses as well. So let's say in normal Creo you want to check for available licenses. It's quite a lengthy process. With this tool you could simply go and say show me all the licenses, and it will go and list all the available licenses that you have access to for that startup configuration. If I change it to just another one and check that to see can I use this license, that will then go and show you that there's one license available for this license type. Then when you look at your configuration command, so normally in Creo we'll have one config file, config.pro, and maybe a config.sub, but then you might have to create multiple copies of these files or this config file if you have people working on laptops or different locations. Maybe the one guy's working on the C drive, another guy's working on the D drive. So what we can do with this starter application is go and split the config file into multiple individual smaller config files. So if you look at the second file on the list, it shows that there is one for all the core settings. So those might be the settings that will be the same for all the users, for all the different divisions that you want to use. And then the next one, the one that's got the underscore dir underscore file in it, will be an example where people could have different file path locations. So like I said, maybe one is on the C drive, maybe one's on the D drive or a map drive, and you can then have all these different files for the different startup commands or different areas or divisions in your business. And when the user starts up that configuration, what the starter tool will do is go and take all those different configuration files that you've specified for that unit, combine it into a single file, copy that into your text file as your config.pro and then start up of that configuration. So it also gives the user the option to unselect certain options or have more control over your startup commands. It might also be that you don't want to have something as a setting that the user must always select or have active. Maybe sometimes they need to open up a really large assembly and you don't want to go and change all the config options. You could have the option available where you could have as a selection box where the user can specifically go and select that tick box, and that will then add specific config options for that startup command to change the environment for that session only. Then if we look at changing these config files, we also have a nice built-in tool into the application where you can go and edit the config files. So normally you would have to do that either inside Creo and then export the file and then copy it to the network, or do it in a text editor, but then you don't know what all the options are. So in this tool we have all of that built into one solution. So you could open up in this application in the editor, and this will then show the user all the available text options. You don't need to go into Creo to find all the options. It will show you if you've got any hidden options or any invalid options or any duplicates or default options. So this example, if I type something and don't put in a value, you'll see in the bottom left hand corner it shows you that there we have the option where maybe the guy hasn't specified the values. If you then type that in, it will then come up and say, okay, this is a valid option now, but there's still a warning sign, it's highlighted in yellow. It can also show different versions and different builds in that list, so the user can easily see what is the available options in that build if you want to compare items. And then you can save it, and when the user then starts up Creo, it will launch the software and it will then have that configuration setting set. And if you're using the other option, the next one was the GENIUS Tools that runs inside Creo. This is an example of the interface. It's not a separate program. These are all tools that's built directly into Creo that the user can use. So what does these things look like? So this is a example of all the options you get in part modes. We've got the library tool, the parameter manager, some forms, and I'll show you some of these examples in this presentation. We won't cover all of them, so if you need more information on all of these other options that's available, please feel free to contact us and we can have a discussion about these options and how you could benefit from those. So for this presentation we'll mostly focus on the forms in the part environment that we used for the Bollhoff project, and we'll also share the parameter manager and the library. And you've got different options for part mode, assembly mode. In assembly mode we've got a nice tool for exporting your bill of material information. If you want to import that into an ERP system and you may be not using a PLM system that does that, we can export from directly from your assembly into an Excel file that you can then upload into your ERP system. And there's also options in the drawing mode for creating tolerance tables, inspection revisions, and multiple other options as well. So the first one that we'll look at is the forms. So what is a form? It's a tool that allows you to access multiple items in a model in one window. So in a design, if you've got a parametric design, you might want to change something like this trailer. If you want to change the length, you'll have to go to the beam on the side, find that component, find the features, double click on the dimension, change it, regenerate, and then go, if you want to change the width, go to the right beam and follow the same process. So all of this can take a long time. It can be difficult, especially if it's something that someone else has modeled and you need to work through that to find all those options. So you can eliminate all of that by putting all those items on a single form and a pop-up window on the model, and you can then easily go and change the values that you need to change, either by typing it into the text box or selecting radio buttons that will allow the user to only select certain values. Or you could set up drop-down boxes as well. You can group items in separate tabs. You could have images at the top. If you pick on it, it will then pop up and give you all the information that the user needs to do this operation, and also have some steps in the text box next to it that, or instructions on what the user should do. So what can we control? So from the form we can control dimensions, tolerances, parameters. So parameters in components or feature level, so or at the top level. We can suppress and resume features, we can replace components, you can have map keys inside the form, you can assign material from it. So there's quite a lot of information that you can access directly from a single window. and all this information in the form is saved in the actual file. So it's not another separate file that you have to manage and work with when you work inside a design. The next option we want to look at is the library editor. So this allows you to have a nice graphical interface to all your library components. These components can sit in Windchill, or it can be in your local drive or a network drive, and it will then allow you to access the files or information in the or use the information in the file to quickly access the item and find it in the library. So if you have a bolt as an example, the bolt part name might be something like ABC123, and then if you don't know what that is, you can't easily find it, or you have to go into Windchill and search for it by the parameter, and you have to make sure that that parameter is then designated. If you have using it in the library, you can specify any parameter in the model and then search by any parameter. So you could search by the description value, you could search by a supplier value, you could search by a length, or even a dimension value inside the model as well. So once you've used this tool, you found an item, you can drag and drop it into your assembly, or you can open it, or you could also make a copy of it and then assemble it. So there are many different options. It also supports multi-language, so it could be that when the user in the UK starts it up, he might see English next to the actual picture. If you have another user sitting in Germany and he opens it up, he then will get German next to the actual item on the screen. Then the other tool that's quite a nice one is the parameter manager. So this is a way of accessing all the parameter information inside your Creo model, but with a more advanced interface option. So with this tool, we can go and group parameters together in tabs, so you only need to specify the items that the user needs to see. It will not show all the system parameters that you would normally have inside your CAD tool. And you can also then use this tool to add parameters to, or missing parameters, or any old legacy data. So if you have a old file that needs parameters added to that part, you could use this tool. You don't have to manually go and add all those parameters to the parts to show the information on your drawing or access it into Windchill. When you use this tool, it will show the parameter. You can then enter a value, and the moment you click on save or save and close at the bottom, it will add that value to the component. You could also set up pre-configured lists, so you could use this to restrict the user input, so that make sure everybody selects the right values or put it in the right format. You could go and set up values that are linked to other parameters. So in this example, if I specify the color code, maybe if you know what the color code is, you can just go and select it. But if you don't know, you can go to the option just above it. It will also then have a drop down box, and if you select the item to be white, if it's set up in the background through a Excel file or a CSV file, all the values that the user would use, it would then know that if it is the color is white, it might be the RAL color might be 1000, and so it will automatically assign that value based on other items that you've selected in the parameter list window. You could also tell it to autocomplete information, so if you need one complete values such as the drawn by, approved by, the date information, it could be a single click, or like this example, the dimension box information. So how big is this model, the box size around it. It's a single click and it can complete all those values for you. You could also have links to external files, so if a user wants to specify the material finish, he doesn't know what are the available options, you could have it so that if he clicks on the parameter name on the left hand side, a pop-up window will appear that's then a link to an image like this example, where the guy can then go and look at it and specify the valid option that he should use, or the RAL color library or the library item. So it's all available options that the user can go and select. And you can also update multiple parts in the assembly in one window. So normally you would have to go and open each part, change the parameters. With this window interface in the same window, it will show me the bill of material, all the components on the left hand side, and I can simply go and click on the next item, and then it will show all the parameters for that part. I can change them, click on save, click on the next part, change the values, click on save, and that way I can do all the components without having to open up each window in a separate window. So how did we use all this information in the Bollhoff project? So currently in the Bollhoff project they have all the helicoil information inside an Access database, and they would then go and do all sorts of manual calculations, or in Excel do their calculations, and then that would populate the information in the Access database, and then these items would then be linked to drawing sheets or images, where the images on the or the values on the images would update based on the values in the Access database. So there's no real intelligence in the drawing items that's displayed on the drawing. It's just lines and text that is static images. So in this database they also then had about 4,800 components or instances or variants of helicoils that they've created over the years, and they've then compiled all of this and exported this to an Excel spreadsheet, which then contained all the data for all the helicoils that they've created in the past or manufactured. So what we had to do is to say, how can we go and capture all this information in a single 3D CAD model, so that that would be the single source of data. And we remodeled the part, and it consists of 37 features, so it does look like a lot of features, but we had to take a lot of things into consideration. So they wanted to create this helicoil with the tang, the section at the top that can break off. They want to have a simplified version of the model. So we created this model so that we can get all those different variations from a single model, so that we don't have to manage multiple files. So we also then had to go and create 174 parameters for each one of these models in the template model. So it's quite a lot of data that had to be entered into this helicoil coil. There's also 71 calculations or relations inside this model. So this is then to go and that drives the model based on the input values that they've entered from the data sheets into the form, and also some output values. So they, as an example, want to know what is the length of wire needed to manufacture this component. So we used all the information to calculate that from the model, and then that is put back into a parameter value as well, and things like the mass, all those standard parameters that you would normally want from a CAD model as well. We also then used the program tool inside Creo to create the 3 different variants of the model. So if the user changes a certain parameter, it will then change the model to be the model with the tang, so that's the section that breaks off, or the one without the tang, or be a completely different model where it's just a simplified version of the model, so that they could use that in their models and not have a model with complicated geometry if you need to have many of them inside your design. So from this 2D or 3D model, we then also created 2D drawings, or a 2D drawing with multiple sheets in it. The first one was the one that's used for manufacturing. They've then got another drawing that goes to the quality department, another one that goes to the customer, and then one to the supplier to specify the material that they need. So all this information comes from that one single file. So if they change the values inside the 3D model, it will then update for the manufacturer, the quality, customer, and supplier. All those different drawing sheets would update directly. So why did we use the GENIUS tools for this project? First of all, it allowed us to synchronize the data between the UK and the Germany offices. So it's easy to update all the information that's used in the form. There's lots of CSV files in the background, the color files that we use between the different objects, so that if they change the material from one to another, the colors would update correctly and have it all available to everybody in the different design offices. And what would happen, so it would synchronize the data from the UK folder and also to the German folder through the starter application. Why did we use the form for this project? So because it allowed us to access multiple items in a single window. So we had that list of parameters, 179 parameters, so it's not the easiest thing to do it in the normal parameter window if you have that many parameters. And we could also go and group related items together. That makes it easier to work with the data. So they have the main selection, the different wire sizes, the helicoil dimension, information that goes on the customer drawing, some internal parameters that will only be used inside the company, that's not nobody else can access, or just inside the department, and then also the export options, available options for exporting to the 3 different step files. Okay, and then we then put all this information in the forms, and users can access it through the different tabs. So we've grouped them together. We've set up some auto-completed fields, so you have drop-down boxes where the user can select some items, and in these examples all these items are loaded from a CSV file. So we've just blanked it out, as there's some data that we cannot show in the presentation. But once this data is loaded into the form, the user will select an item at the top, and that would then go and auto-complete other values in the field. So if he selects the one in the green area as an example, by selecting something from that drop-down box, it would complete 33 other parameters inside the form. If you change it in the yellow one, it would complete or change 21 other parameters inside that form as well. And also the option to go and export all the step files or open up the model in just that one configuration. Then the next step was to go and transfer all this data that they gave us in the Excel file. So we needed to convert that into all the different components. So we looked at all the data, and then from that main master model we created 4 template variations of the design. So we had the one with the free running with the notch. So the free running is the one without the red section in the middle where you have the grip screw in it, and then the screw lock is the one with the red, and then we also have the option or the variant of it that's notched or unnotched. And for each one of these variants we then had the 4 different drawing sheets which would then show the different parameters. So some of them we had to remove values because we don't have the grip in there, or we don't have the notch in there. So it was a quick and simple task to take the items off after we've added everything to the original drawing template. So we then went and created the different variants inside Creo, so all the different models based on the 4 templates. And once we had that, we then had to go and update all these variants with the data from the Excel spreadsheet. So these templates will also then be used for future new designs, so that if they start a new design it will copy the part and the drawing, or they could also go and make a copy of any of these 4,818 items as an existing one, make a copy, and then just change the values and update, and it will update the model and all the drawings as well. So it's a simple process to create new items in the future. So to update all these different variants that we've just created with the actual sizes to make sure it's got the right size in each one of the models, we use the model processor application. So that's the GENIUS Tools Modelprocessor tool, and this tool allows you to basically go and take any Creo data and rework that data to whatever specification you specify. So you could do it on just a single model, or you could do it on everything that's in session or in a workspace. So you could open an assembly and say complete all these tasks on a certain item, or you can do it in a batch mode. We could say these are the 500 file names and go and run it on these files to complete the task. So we've set up all the tasks. You could have multiple tasks, it's not just one at a time. You could say do a lot of operations on a model, save it, then go to the next one, do all operations and save it again. So as an example, you can set up tasks for just a general working environment, so config options before you start this tool. You could go and set individual settings in the environment. You could set Windchill settings. You can specify tasks in the model, in a drawing, and also for reporting information. So some examples, if you expand the options on the left, it will then say for a model parameter, you can as an example go add parameters, change parameters, rename parameters, delete parameters, designate the parameters, or add relations, or work with family tables and split tables, or delete tables, or verify them. So there's a lot of different options available inside this tool that you can use. So for this Bollhoff project, what we did is we added 115 tasks per item or each model that we had to go and update. So the first one was just a simple thing of saying take all those parameters that we had in the list and bring all those parameters into the model and then update those values. Then the next task is to go and assign a material to the model. We then updated the parameters, so as we had to go through a change process when we did all of this, we had to go through 3 different iterations where we did something, they realized that we needed to make a change, and we then had to run it again. It was a simple process of to go and say, okay, go and delete a parameter and that they don't need anymore, and go and add a new parameter and just rerun this batch operation for all the models. We added relations, we updated relations, we set the colors based on the material that's been assigned at the top, so it will go and check if you've used a certain material, then go and assign an appearance. We also added secondary parameters from a CSV file based on the original parameters that was loaded in with the data set. We did this because there was a lot of the parameters where you added if a certain item is set to this value, maybe the finish is set to a certain value, the secondary finish that goes on the customer drawing must be a similar but not exactly the same value. So we had a second list that will say if it's this value, make the other one that value, if it's this value, make it that value, and that way we could then simplify the process of updating all the models. And then once we've added all these items or updated all the items to the model, we would go and regenerate all, so that's updating the model to make sure it's done, and then save the model. And then what we did as a final check is to report the information out again from the model so that we can compare that with the original CSV file to make sure that all the relations is working, everything was verified correctly, all the parameters have been completed, the model is regenerated correctly, and just to make sure that everything is correct inside that model. And then for the drawing of that model, we also added some parameters as we went on with this project. We also then copied information from the model to the drawing so that you could see it in the actual drawing itself or inside Windchill for that drawing. We had to replace some drawing borders as we went along with this whole project, so they made it some changes based on the different languages, where they've got some text they wanted in German, some should be in English, or combination of the two. And then we had to go and update all the sheets, save all the drawings, and then also go and create step files for all these items. So if we had to do this manually, we did a test on a couple of them and say it would take you 15 minutes to enter all this information manually. This would mean you have to sit with the Excel spreadsheet, open the CAD model and go and look at the parameter and type it in, go to the next parameter and type it in. So it will take 15 minutes, but you can still make mistakes if you have to type in all those values manually. So if you have to do all of them manually and it takes you about 15 minutes, it would take you 150 days of effort to sit there and do this project. And that would mean someone had to sit there 8 hours a day, Monday to Friday, to do this work. And we've went through this process 3 times, so we had to make 3 sets of changes, so that would be about 450 days of work, and that's just working weekdays. So it would be more than a year to make all these changes to the data. But with Modelprocessor, it only takes 20 seconds per item. So that means instead of taking 150 days, you can do this in 3 days with very limited user input. You need to specify the items where you want to write the report to and which files it should work on. So it's a list of the batches. So we did this in batches of 500 files and started. And when you start it, you can carry on with other work on your machine while this is running in the background. So the interface, and then just some example of what it looks like. So it will show you the process. So it would go and open the model, change all the values, regenerate, save it, go to the next part, regenerate, save it, get to some drawings, update the drawings, replace the sheets, do all of that, and go to the next item. So this takes about 20 seconds, so the movie shows it a lot faster, just so that we don't have to sit and wait for 20 seconds for each one. But it's just to give you a representation of how the software works and how quickly it goes through the process. So we did all of this, and then once all of this was done, we still had some manual work to do. We had to go and open each one of those items and just go and verify that we have all the right information on the drawing. So if you load the model in, some of them will be big, some will be small, so we have to go and change things like the scale on the drawing and maybe clean up some dimensions, just moving the dimensions, moving the notes around a little bit, just to make sure they're all look the same. So that's about a minute that we had to spend on each of the drawings. And in total, it just takes us 10 days for each cycle of working on the data. So the next step on this project, we have to finish off this data. So there's still a couple of items we have to check. And then what we'll do is take the German data. So the whole idea of this project was to consolidate all the data from Germany. They have their own Access database that is created completely different from the UK one. So it's to consolidate all the data from both the UK and the German design office, and then bring that all into a single CAD platform into Windchill, where they all will use a standardized system on both sides of the company. And there's also then some ongoing projects for the future on the Windchill side, so that is something that is discussed at a later presentation as well. So I want to thank you for your time. If you do have any questions on any of the things that we've shown in the presentation, please feel free to contact us and we can set up another session to discuss all of this in more detail. Thank you.